Today we are going to talk about stacks. So to demonstrate it, to explain the concept of stack, let's see the example of this casserole, right? So we put rotis into it or tortilla bread into it. So uh, whatever we put into it, whatever roti we put into it, uh, we can only take out the top one, right? So there is another concept for this called LIFO, or last in first out. So the last roti that goes into it is the first that comes out. So whenever you take out any roti, right, so only that roti comes out which was the last to go in. So this is basically what stack is. It's useful in many algorithms. We use stacks. So we'll first see how to implement it and what are its uses. So let's implement a stack. I'll create a directory. Let's call it stack demo. City stack demo, and then I'll open this in Visual Studio Code. Yeah, so we are into this folder, and I'll have a index.html and app.js. So I'll write a simple HTML here. And I'll link the app.js file. Now I'll open this in browser and we'll see how it looks like. So it will be empty right now. You can see stack demo. I'll open the console. And then now we'll start working. So we want to implement a stack, right? Something where when you take out something, so what comes out is the last element which went in. I'll implement a class, say stack, and a constructor. So when you instantiate this class, I'll create a empty list of items, and we'll have methods for pushing into this stack and taking out elements out of this stack. So commonly they are known as push and pop. They're commonly known as push and pop, and there are some utility methods like is empty, to know if the list is empty or not, something like this, or just know the element which is on the top, right? So there are methods like this. So we'll try to implement this. And here I'll create a instance, new stack. So first we need a method to push items into the stack. So let's take an element, or let's call it EL, and push it items dot push. We can write array. JavaScript arrays already have two methods, push and pop, so we can use JavaScript arrays directly as stacks, but we'll not use the already existing methods. We'll try to implement them. So what I'll do, I'll maintain a count. This dot count equal to 0. This dot items, this dot count equal to here. So when the list is empty, count will be 0, so the element will go in the first position. If list has say 2 elements, then count will be 2. So at position 2, because the array starts from 0, 0 and 1 will be the 2 elements which are already there. 2 is there is nothing at 2, so we'll put the new element at position 2, and then this will increase the count. Similarly, pop basically removes the last element and returns it. So we can do something like this dot items, this dot count delete. I guess this should work. If it doesn't, we'll see. And first we'll store it somewhere. Select last element equal to and return last element. Is empty or not, we just check this dot items dot, or this dot count is there, right? This dot count equal to 0. Peak should return the last element. This dot items, this dot count -1. So if there are 2 items, then the array is 0, 1. That's why this dot count -1. So we just know the last element. So let's see if things work. Here we will write some code, and I've used HTML CSS just so that we have a visual representation of this tag. And yeah. Let's have a button. On click equal to add a random number. Add random, something like this. So this will add a random number at the end of the stack. So let me create methods here. Function add random. So it will do stack dot items, stack dot push. So let me create a new random number. New random number I want it between 0 to 100. So math.floor math.random. So it gives me a number between 0 to 1, and I multiply it with 100. And the stack, I'll push it into the stack. New random number. So I'll push the random number, and I'll create a method to refresh display something, or render stack to show the stack on screen. ID equal to stack. Here I'll do something like this. Document dot get element by ID stack. Save it somewhere. Const save stack on DOM equal to this, or stack DOM element, and then I'll first convert it to a string. Let's create a method to a string. So this dot items dot to a string, or dot join I'll just put it like this. And then a stack DOM element dot inner HTML equal to stack dot to string. So whenever we make any change in the stack, I'll call this function render stack. So let's see how things look like. So you can see when I click on add rum number, so it prints me undefined. So let's see what the issue is. So when I click on add random, a random number is generated. It is pushed to the stack, and render stack is being called. The stack is dot count equal to 0, this dot items equal to. Okay, I did not write return here. Should work now. 52, 18, 28, 59, 90. You can see items are being pushed towards the end. I'll get rid of this console.log, which I added to debug things. So you can see I can keep adding numbers at the end of the stack. Now I'll write a method which takes element out from the end. I'll create another button. I'll remove last element, remove from end, and I'll implement it. Function remove so I just have to do stack dot pop, and then I'll just do render stack to know what happened to the stack. So you can see if I add, if I remove, yeah, stack.pop is not working. Let's see. So it returns and I did not do this dot count minus minus, and delete is not working. You can do undefined. You can see we can add numbers at the end, and we can remove them also. Now you can see the problems with these empty lines, right? So it is happening because the array is instantiated, the elements are there, but they are filled with undefined. So let me take it back to delete and see what happens. So delete doesn't work either. So when we do to a string, we have to take care of the count. For example, this dot items dot slice only go till that count, slice 0 to this dot count -1, something like this. Let's see. Added a bunch of numbers. Yeah, now it is working. So you can see this is stack, right? So last in, first out. So you can, whenever you add, it adds at the end. Whenever you remove, it removes from the end. So this is what stack is. The actual implementation, it is used in a lot of complex algorithms. So we'll see as we cover stacks, or as we cover algorithms in more depth later.